Welcome guys to another tutorials on statistics. My name is Samuel Endo and I'm doing the tutorials from my math book. Today's tutorials I'm going to take a look at empirical rule, and what the empirical rule is for us to be able to know where the data will lie within a distribution. So when we partition a distribution from say 1 to 100%, what it is when we find a data, I want to know where this data is going to fall within that partitioning. So the empirical rule gives us a very good way to do that. And what it says is that when you have a data which lies one standard deviation away from the mean, then that data will fall about 68% within the distribution. Also, it says that if you have a data um, which lies two standard deviations away from the mean, that data will lie within 95% of the distribution. And finally, it says that when you have a data which lies 3 standard deviations away from the mean, that data will fall within 99.7% of the distribution. So let's go ahead and grab a distribution, normal distribution curve, so that you see where we have a data where it's gonna fall. Now, given this distribution, we see that the horizontal part is our standard deviations. So say we're able to calculate a particular value, and our standard deviation is one standard deviation away from the mean. So we have the mean, and no, we have a value, and that value is one standard deviation away from the mean. That value is going to fall within this percentage, 68.26. Now we have another value, and that value fall within two standard deviation away from the mean. Now if it's two standard deviation away from the mean, that value will fall within 95% of the distribution. And finally, when you have a value and that value fall within 3 standard deviation away from the mean, that's from the mean is 3 standard deviation away from the mean, then that value will fall within 99.74% of the distribution. Finally, what I want to talk about is when you are asked to estimate the percentage that a particular value will fall within, it's gonna fall from the right side of the it's gonna fall from the right side of the for the mean. So say you're able to get a value which is 2 standard deviation away from the mean, that value is gonna fall. You have to add 34.13% plus 13.59%, because from here to here is a value that has 2 standard deviation away from the mean. On the other hand, when you have a value that fall within just one standard deviation away from the mean, the percentage you have to give it is 34.13%. I hope this is understandable. So let's go ahead and take a question and answer that question. So now hold on a second, I'm going to grab a question for us to take a look at. Well guys, I was able to look at this question, which is in a survey conducted by the National Center for Health Statistics. The sample mean height of women in the United States aged 20-29 was 64 inches with a standard sample deviation of 2.71 inches. Estimate the percent of women whose height are between 64 inches and 69.2 inches. So solution here, we have a solution, sorry about that, and we say that the mean was given to us, and the mean was 64 inches, and it gave us a standard deviation to be 2.71. Now they want us to estimate something here. What are we supposed to estimate? Let's estimate 64 to 69.42. Alright, we have this. Alright, first we gotta do is to be able to know the value for one standard deviation away from the mean, and we also have to know 2 standard deviation away from the mean, and we also have to know 3 standard deviations away from the mean. Now when you get good with that, you don't have to do all the 3 all the time. So let's begin. So let's estimate the first, which is so we're saying that so we have this value So the mean plus standard deviation, or one standard deviation away from the mean, is what? The first one. So let's find the mean. It is 64. We add it to one standard deviation away from the mean, and that gives us 66.71. And then let's take the next one, which is 2 standard deviation away from the mean, and that gives us what? 64 plus, now it's gonna be 2 times 2.71, and that gives us 5.42. all right, it's gonna be 64 and the total is going to be give us 69.4. So we have these values here. All right, so we are asked to estimate values from 64 to 69.42. Now this is like an estimate here. This estimate here is a class estimate. So we know that the mean is 64, so we didn't have any deviation. So let's go ahead and estimate the 69.42. Now the 69.42 is 2 standard deviation away from the mean. So once you know that it's 2 standard deviation away from the mean, it's automatically within the 95% picture. So we go ahead and write down that percent of women whose height is I see the 95% picture. 10% of one whose height is this lies within, let me say lies within 95%. So you have that lies within this 95% picture. But if you want to find the exactly, we should estimate the percent of women whose height are 64 to that. This is the 95% picture will be from all the way from the left and all the way from the right. If you take a look at it, it's all the way from the left, all the way from the right. But 64, which is 2 standard deviation away from the mean, will be somewhere within here. So you always have to divide the distribution in half to get the actual percent of women whose height is 69.4. So we're gonna divide that, and that gives us half of that, which is half of that 95%, and that's gonna give us what we're looking for, which is 47.5%. So this is our final answer, and this tutorial we're going to take a look at Chebyshev's theorem. I hope this tutorial went well.